Okay, we could finish up the problem to calculate the peak force in the shell and then the peak stress. And if everything is correct, the peak stresses should be comically low, something under 100 psi, something like your bike tire. So this is a force diagram, and the worst force will be the first segment near the, we call this the springing point or the ground where the foundation is, and it's leaping upward. So these two edges have to be the worst. So you take the longest one. Let's just take the first one. It looks pretty symmetrical here because my crown was in the middle. This segment, if you hold your mouse over it, for me, it's segment Q. That is a segment, but remember this is scaled. We had the force scale. So segment Q, let's go find segment Q here. It is 18.77, and it's not 18.77 pounds, it's 18.77 times the force scale. So we could calculate that really quick here. Peak force is, and don't type 18.77, you could just say length of left parentheses of Q, which should be 18.77 times the force scale, not divided by the force scale, but multiplied by the force scale. And that should be 1,942 pounds. Remember, the weight was 2,700 pounds here. So we could put that in as dynamic text, which is pretty cool here. Peak force pounds is, that's just English text, and go to your drop down and find peak force here. So that's pounds, and now the stress will be that force, the peak stress will be that peak force divided by the cross-sectional area. Just be careful with units here because our width was in feet, right? 1 foot, and our thickness was 2.5 over 12. So that was also feet. So we want to change that to inches. So peak stress is equal to peak force divided by the quantity, left parenthesis, width, with a capital W, you got to be careful here, width times 12 times thickness times 12. And yeah, look, I got 64 psi, which is kind of what I expected. So we'll do dynamic text here. Peak stress is, and then psi, this is all just English, is equal to, and then we can go to our drop-down menu. Peak stress is there, and that's psi. Now, just before we end, make sure we could play with this. So if our rise was much lower, these numbers would dramatically increase. So let's say it's 12 feet instead of our 20 feet. We just have to satisfy the boundary conditions by tweaking the pole a little bit. And look, it's got to grow. And, we'll call that good here. And even that's really low. Okay, thank you.